All right, so now I'm at the bottom of page 210. We have this chart that we're going to fill in. I'm going to do something kind of obnoxious with my notes because I want to be able to see the curves. I'm just going to draw the curves all over this paragraph at the top, right? Problem without graphing, fill in the table below. You're filling blah, 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 blah. All right, so first row is for 9 plus 9 cosine theta. So I kind of generally know what that looks like. Let me get a color that I want to use. So oh, there's like dots here. What are those? I don't know what those are for. All right. So I'm gonna pick black, and I know that this sort of in general. I mean, this is like really obnoxious, but I only need like an idea. So it's gonna be like this, and then like this, right? And I know that at theta equals 0, I'm here, and then I'm gonna go counterclockwise. So if you think about it, when theta equals 0, you're like all the way out, or just do the math. When theta equals 0, you get 9 plus 9 because the cosine of 0 is 1. So I know that I'm going to be at the polar point of 18, 0. But in rectangular, just like where are you? In rectangular, you're actually just at the point 18, 0 as well. All right, then what we're going to do is we're going to swing up to here, right? And so that is going to be in polar. The angle is definitely pi over 2. I am 9 units away. I'm doing this. I am 9 units away from the origin. So in polar, that's going to be 9 comma pi over 2. But think, in rectangular, you're just on the y-axis, and you're 9 units from the origin, which means that you must be at the point 0, 9. You really find out how much you talk with your hands when you do this kind of thing. I feel like 35% of my teaching maybe is based on me moving my hands around. So we're missing out on that. All right, the next thing we want is pi. So at pi, at pi, I'm here, which means that I've gotten back to the origin, right? So the radius is 0, so that's going to be 0 comma pi. But then if I'm at the origin, I know that the rectangular coordinates are just 0, 0. And then, woo, it does this like bounce back thing when it like, I don't know, what is it doing? All right, so 3 pi over 2, we're going to be there. Had a lot of trouble drawing that arrow. So 3 pi over 2, we are 9 units away from the origin. So we're going to get, we're 9 units from the origin, so that's 9. And then 3 pi over 2. But then in rectangular, you're 9 units below the axis, which means that you're at -9. So x is 0 because you're on the y-axis, and -9. So that's how you can fill this in. And then what you want to do is just kind of like fill in the rest of it. So I'm going to sketch them. Then I'm just going to like fill them in, and I'm going to hope that I'm right. So a negative sign thing, right? So sine wants to start here. Negatives can be predominantly on the negative y-axis, sorry. And I'm going to roll. What am I going to do? I'm going to rotate. I'm going to rotate counterclockwise. So we're here, we're here, we're here. I think that's the best one I've drawn yet, and it's still not great. Okay, so think about what we did. We're at 6 when theta is 0. And in rectangular, that's actually just 6, 0 because you're on the x-axis. We're at the origin, so the radius is 0 when theta is pi over 2. In rectangular, if radius is 0, you're always at the origin. Then we keep going, right? So we are again 6 away when theta equals pi. But if theta equals pi and you're 6, positive 6, that means that you moved. Can't figure out which way I would point for you on this. Anyway, you're at -6, 0. Like that. And then we got 3 pi over 2. 3 pi over, there's also like a little bit of lag with the way that I'm recording this. So it like maybe messes with my mind more than, I'm now realizing some of the things that are weirding me out, you might not even see. But maybe you do, I don't know. Yeah, there are no comments probably for this, but let me know in the comments. And all right, so 3 pi over 2, I'm going to be, where am I? I'm like totally lost here. 3 pi over 2. there I am. All right, so I am 12 units away from the origin, and my angle is 3 pi over 2. And then I'm on the negative y-axis, which means it's 0, negative 12. All right, let's take a look at the next one, a negative cosine. Okay, so a negative cosine, and again, I'm just like, I don't recommend you take your notes this way, but unless you like need to see it and you don't have any available space, in which case, go for it. All right, let me fill this in. So when theta equals 0, I'm actually at the origin, which will still be the origin. And then when theta equals pi over 2, I am on the y-axis. So get this, and then that's actually the 0.08. When theta equals pi, so when theta equals pi, I'm 16 units away from the origin. So it's going to be 16 pi. And then in rectangular, I'm on the negative x-axis. So that's going to be negative 16, 0. And then 3 pi over 2, I'm 8 units away again. So it's going to be 8 comma 3 pi over 2. And then that's on the negative y-axis. So that's going to be 0, negative 8. And then if we went to 2 pi, we'd get back to the origin to close the figure. So let's do this last one. 1 plus 1 sine. So a positive sign. So the thing that I think is helping me the most on this is kind of twofold. One, I'm just going for it and drawing these. Like I put in a little bit of time and I memorized how these should work. So when I see like a positive sign cardioid, I know that I'm going to start here and go around and there. And oh my God, terrible. Let's try it again. Go around and not as terrible. Okay, so I know that's going to happen. And then also I'm really willing to think, or to try to think in polar and rectangular at the same time, right? Like when it's polar, you have to like think like, what's theta? How far am I from the origin? When it's in rectangular, in my mind, I try to just think like, look at that picture. Where is the point, right? Is it on the x-axis? Is it on the y-axis? And just kind of like go with that. So here, let's fill this in. So when theta is 0, I am, when theta is 0, I am 1 away. So it's 1, 0. And then that's still 1, 0. So this, you might notice these are always going to be the same, because if you're on the positive x-axis when theta is equal to 0, you're just going to get the point in polar and rectangular. They look exactly the same. All right. And then when theta is pi over 2, I'm going to be at 2. And then I'm on the y-axis, so it's actually just 0, 2. And then when theta is equal to pi, I'm going to be at 1 again, so 1 comma pi. And then I'm on the negative x-axis. Why can't I blow you up? Okay, so that's going to be negative 1, 0. And then when theta is 3 pi over 2, we're actually going to be at the origin. So at the origin, the radius is 0. Turk's math stuff, big plug. We're at 0, but the angle is 3 pi over 2. But if the radius is 0, you're at the origin. So 0, 0. All right. I feel like that's enough for this one. And I will be back with more, and let's see if I am better at stopping the recording. Looks that way.